Hello, and welcome to lecture number 1 in the Einstein Math High Performance Program. We trust that you are going to enjoy this program of a number of lectures together with us, and that you will understand some new techniques on how to solve problems in mathematics, even at your level. Perhaps you are in grade 2 or 3, roughly the age group 6 to 8, but we will consider problems that are not considered normally during your class exercises, but which are intriguing and thought-provoking, so that you will want to learn more and be stimulated to want to study deeper mathematics later. So this is a preview of lecture number 1. The proper lecture number 1 will consider all the details thoroughly. Nevertheless, as a preview, we'll tell you what's coming up and give you some hints and ideas on how to tackle some of the tricky problems coming up. Firstly, we will discuss the Polya strategies. Professor George Polya was a Hungarian mathematician, and he wrote a famous book entitled How to Solve It. How to Solve It. You can try to find it. It may not be available easily. You may try online. School library may struggle to have it. It was published in the year 1959. It's a long time ago, in which Professor Polya gave some strategies that one could try out when trying to solve a problem, such as guessing and checking, drawing a diagram, or a picture, or a sketch, or look for a pattern. Now that's the important idea we're going to be stressing in lecture number 1. In fact, many people consider mathematics to be a study of patterns. And when you develop the skill to read the patterns, then your skill in mathematics can improve, and then you can tackle and solve some of the difficult problems perplexing mankind, not only in mathematics, but in other areas of life as well, such as in medicine, agriculture, engineering, and other areas. Now, unlike the problems that you come across in school, the problems that we will discuss in Einstein Maths can either have one answer. The word solution means answer, or they could have many different answers, or they could have no answers, no solutions. So you will see some problems in the course which will be of that type. Now we're going to start off the program with the first problem, but it's in the form of a game, so you can try it yourself. Why not try this with your mom or dad? It's called the 21 game. So the first player says 1 or 2, the number 1 or the number 2. 1, 2. The next player says the next number or the next 2 numbers. So each time you play, you have a choice of either taking one number or the next 2 numbers, and so on. And the first person who says 21 is the winner. So if you go from 1, 2, 3, 4, 5, 6, 7 onwards. So suppose you are the first player and you choose 1. Now the next player may choose 2 and 3. You may choose 4 and 5. Your opponent may choose just 6, and so on and so on. The first person to hit 21 is the one who is going to be a winner. Now, if you think very carefully about this and try this a number of times, you'll see there is a strategy that one should follow. So that's why we ask you these 2 questions. Can you find a winning strategy if you play first? Think about it. Can you always win if you play first? Or can you find a winning strategy if you play second? Perhaps there is a way to win if you play second. Think about it carefully. So try this out with your mom or dad or your friend or your neighbor and see whether you can win and what the strategy is. I'll give you a hint. There are some magic numbers you got to get to. If you get to those numbers, you will win. Right now you go and find what those numbers are. A slightly harder version of this game is called the 21 game harder version. So here we have the same problem, except that now you may choose to say 1, 2, or 3. You may choose 1, 2, or 3 of the next numbers coming up. Again, the first player who says 21 is the winner. So if we start off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, up to 21. So suppose you play first and you choose 1, 2. The next person can choose either 3, 4, or 3, 4, 5. So let's suppose the next person chooses 3, 4, 5. Then you have a choice. You can choose whatever, 6, 7, 8 if you like, and carry on like this. Now the first person who says 21 is going to be the winner. Again, can you find a winning strategy if you play first? How about if you play second? Think about it very carefully and see if you can come up with a winning strategy depending on where you play. Next up, we're going to discuss a series of patterns. So the situation becomes study of patterns. So we're going to discuss a large number of patterns that are very interesting. So under these patterns, as I said, one of Polya's techniques is to find a pattern. So I'll give you a hint. What you can do with these patterns, try to read them aloud to yourself. Look at the first one. 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2. All right, so if you read it that way, you'll see the pattern is very clear. You've got to find a way to read the pattern also that will help you to see exactly what the pattern is. If you look at the second one, 3, 4, 2, 1, 3. 4, 2, 1, 3, 4. I don't think I read that correctly. Can you find a better way to read that so that you can see the pattern? I'll leave that to you to try out. Okay, now let's go to the next one. These are the ones I'm going to leave out for you to try. You can see how they work. They're quite tricky, some of them, but some of them are pretty easy. Fill in the blank boxes. Again, these are not too difficult. If you read the pattern carefully, you should be able to fill in the blank boxes, even for these patterns that have been drawn for you. Okay, sometimes the pattern has got missing numbers in the middle or somewhere in the middle, and then you can try to guess what those numbers are going to be. Finally, at the end of the lecture, we are going to consider some problem-solving questions, which are quite challenging. Now, in the first one, the question is, in which number spot is the car parked? Here's a car here. If you look at the number here, it says 16, 06, 68, 88. Then there's a blank here. What number is that? And 98. Do you think there's a pattern there? Can you think of the number that the car is parked in? Well, we will show you this in the lecture, but we would like you to think carefully about this. What pattern can you think about to discover that missing number? Okay, now let's take some of these number patterns that we practiced earlier on. This one is a bit tricky. 10, 12, 15, 19, 24. What comes next? 10, 12, 15, 19, 24. What comes next? Think, think, think. How do you get from 10 to 12, 12 to 15? Okay, think through that. The next one is similar. Fill in the blank space. What number goes in between? 7, 9, 13, something, 27, 37. Interesting. Okay. Number 4 is also quite interesting. 2, 3, 5, 6, 8, 9, 11, 12. 2, 3, 5, 6, 8, 9, 11, 12. It doesn't sound to me like to be a pattern, but we have to think carefully. There is a pattern hidden in there. Can you find it? And the last challenge that we are giving you here is to look at the pattern given here, and can you work out the missing pattern? If you count up, you'll see there's 1, 2, 3, 4, 5, 6, 7 that way. 1, 2, 3, 4, 5, 6, 7 this way. Actually, there are 49 blocks. Now you got these patterns: donut, donut, spiral, donut, spiral, triangle, donut, spiral, triangle, square. The new guy appears. Donut, spiral, triangle, square. Oh, there's now a new guy. Hexagon, 6 sides. Right, now carry on like this and see if you can find a pattern. You have to decide how to read this pattern. Now, could it be, which direction should one go in reading this pattern? Well, you got to think very carefully. What will be the best way to proceed here? Should we perhaps go down the loop here, go around this way, and so on? Would this be a good way to go? I don't know. I don't know. I don't know. Could it be a good way to go? Or maybe the good way to go would be to go this way. Like that. Snake down there. Maybe there's a way to see a pattern in that. Is that going to work? I don't know. Well, you're going to try this out. So you're going to find any way that works. Maybe you have to go down the diagonal. I don't know. Go up there, go down the diagonal. How does it work? Oh, you've got to think this through, right, guys? So that's an introduction and a preview of lecture number 1. We would like you to think very deeply about this. And when we discuss lecture number 1, we will consider all these solutions. See you then.